is mandatory to receive a certificate. Today's topic for the webinar is Climate Smart Rice Hybrids by Dr. Jauhar Ali, a senior scientist at the International Rice Research Institute in the Philippines. Dr. Ali, a hybrid rice breeder, is a pioneer in his field of research. He has significantly contributed to the development of multiple stress tolerant inbred and hybrid varieties and capacity building for strengthening global agricultural research. He has developed and characterized 8 thermo-sensitive genic male sterile TGMS rice lines, for which he was awarded the Jawaharlal Nehru Award for outstanding PhD thesis research work in 1994. This work led to the discovery of the genetics of the TGMS gene and to the understanding that TG genes, TMS4 and TMS8, were unique and could be exploited. Using these materials led to the development of several TGMS-based hybrids involving different centers. Currently, Dr. Ali has taken up 2-line hybrid rice breeding at IRRI on a strong footing to deliver the 2-line hybrid rice technology in Asia. He has developed several low critical sterility temperature point TGMS lines that are currently in the verge of commercial exploitation. Also, he has been instrumental to the development of the green super rice breeding technology at IRRI, being the project leader and the regional coordinator of the Green Super Rice GSR project in Asia and Eastern and Southern Africa. Through this innovative approach, he has bred and released 26 rice varieties in Asia and nominated nearly 104 GSR cultivars into national cooperative yield trials. He connects genomic resources and tools to breed superior, high-yielding, multiple stress-resistant rice varieties and hybrids. As lead and regional coordinator, Dr. Jauhar Ali leads the development and targeting of improved rice materials through systematic testing, adaptive trials, and varietal release for 8 countries in Asia and 5 in Eastern and Southern Africa. 56 GSR inbreds and 22 hybrids have been released, whereas 110 are nominated for national yield trials in different countries. Dr. Ali has also established the IRRI GSR breeding front in 2009 and produced more than 530 promising multiple stress tolerant materials shared with NARES partners, INJA and MET. He has published more than 80 peer-reviewed publications. He has also provided training to more than 2,100 researchers, especially on hybrid rice technology, seed production, and molecular breeding. I now request Dr. Ali to begin his talk. If you could please share your screen with us. Thank you.
Good day to all of you in whichever time zones you are on. And I would first thank Subroto for organizing this event under the Bioingene platform with and I really, they deserve congratulations for doing such a wonderful task in a global scale and bringing the science to the scientific masses, and at no cost, especially in these COVID times. I think this is exactly the reason we should congratulate all of us, Shuvo and his team. And with that, let me begin my talk on strengthening global food security through climate smart rice hybrids. If you look at the food security, rather we should look at the food insecurity in the first place in order to do something for the food security. Food insecurity map published recently where it shows the current levels of food insecurity in many countries in Africa and Asia are in light orange color, which shows the food security insecurities are very high. But the situation still goes worse when the global population would be something like 9.7 billion people in 2050. And if you look at the map at that time, it will be something like a very dark orange red, which is a signal that we are heading towards that. And among them, the conditions under which we are going to raise this, the food insecurity challenge, meet this challenge, we will be under climate change. And among the stresses, if you look at the drought, is picking up like anything. And that means heat and drought would be the major factors that would determine how agriculture would survive. Especially the most affected would be crop plants and the livestock. So this is really a challenge that is coming in the coming days. Now, securing the food under climate change is very, very important. And there are 4 elements, the key elements. There are plenty of them, but I listed here 4 important elements out here. The first one is basically the core ingredient, that is the climate resilient crop varieties and hybrids. This is not only for rice crop, but for any variety, for any crop, across crops, food crops, it is applicable. And where we need to enhance the yield potential under both favorable and unfavorable environments. And the same thing can be realized, these hybrids and these varieties gets well expressed if your crop management technologies are properly associated with it and properly advanced to the farming communities. And the other side of the coin is also, when you talk about food security, we have to talk about the nutritional security as well. And this is basically comes when we have to use biofortification approaches, and especially for food insecure and chronic regions of the world. And above all this, the conducive policies and action plans across the policymakers in different countries to keep the food reachable at all times. And that means the food availability, its access, affordability, its utilization and stability plays a very, very important role in the food security plan. And in this picture, the hybridized technology is a very vital picture. You have to understand the context here. If you have to sustain the higher yields and grain quality, hybrid technology is very, very suited for this kind of situation. And in many countries where food security is a concern, where limited land is there is the best option is to switch to hybrid technology, whether it is for rice or even for other crops as well, where the per unit area productivity would be increased. And coming to the self-sufficiency in rice production, many countries have to keep their bowls filled. At times, when you remember when we had the food crisis in 2008, many countries were suffering from the food were not in the shelves. And many of the countries closed their export gates, including India and countries like Thailand and Vietnam and all these countries. But and that's the reason why self-sufficiency in many parts of the world is very important as far as food is concerned. Hybrid technology, when you grow hybrids, it gives about 25 to 30% yield advantage. That means it frees up the land to other crops and other important utilization of the land. If the inputs and the irrigation water is saved about 25 to 30% in the same proportion. And the technology not only it generates a lot of rural employment and seed industry. If you take a typical example of Hyderabad, the surrounding areas of Hyderabad where the hybrid technology is one of the hot centers in India, you see the rural employment in those villages. If you go around, people are well versed how to do seed production, and they are very good in managing those technologies very well. Now coming to the less dependence on rice imports, many of the countries, if they have to reduce their dependence on the imports, then the best option again would be hybrid technology. And especially when you compare with wheat, wheat has surplus of wheat available in the international market. But if you look at the rice, it's somewhere between, it fluctuates between 25 million tons to 40 million tons in the international market. And countries like China and India, whenever there is any crisis, they will mop up all this 25 to 30 million tons in no time, and leaving many countries without any food. So in the coming days, this phenomena would really would be of major concern. So people at different levels, at different countries, they have to look how they can become less dependent on the rice imports. And of course, it nurtures the seed industry to produce quality seeds, not only for rice, but also other crops. And the quality seeds is the best method to deliver the good productivity and increased production in any country. Now, if you look at this map, the graph, you see the area outside hybridized spreading across outside China is almost now 8 million hectares outside China. And this is the potential of this growth in South Asia would go up to 15 million hectares, whereas in South Asia, especially Myanmar, would be around 5 million hectares. And the current area in China is around 16 million hectares. So this is the trajectory that we would expect in the coming days in order to feed to meet the requirement of the extra food that is required as far as rice is concerned. Now, if you look at the core research challenges for hybrid breeding, the first and foremost is increasing the grain yield heterosis. Can we increase the yield heterosis beyond 25%? That would attract the stability, that kind of stability would attract the farmers to adopt hybridized technology. Then the question comes is, can we breed multi-stress breeding for developing the parental lines that would match the market needs in the region? And coming to the consumer and grain quality for the market of the target regions is very, very important. Many times we always associate grain quality with, especially of the hybrids, in relation to the Chinese food requirements where they prefer sticky rices. So immediately the connotation goes that hybrids are sticky. It's not so. Basmati hybrids have been created and they have been catered to the needs. So we can cater to any particular need, any kind of quality is possible through hybrid technology. And then if you look at the new technologies that are coming with the precision breeding approaches, utilizing the informatics on genomics, high throughput, phenotyping, and environments, all this can be combined to create the precision breeding for hybrids as well. And the genomic predictions and artificial intelligence, and to identify heterotic combinations by this approach is feasible now. It's not in the past that it were not feasible, but now it's very feasible. And many countries are looking at this as a big opportunity out here. And the high outcrossing trait breeding, especially, would increase the seed reproducibility. So including IRRI, we are working on this particular topic, and this is one of the biggest challenges. If we can increase the hybrid seed reproducibility beyond 3 tons per hectare, that means we can bring down the cost of the seed so that the farmers can adopt at lower cost of seeds. Coming to the reducing cost of hybrid seeds, we can go to another level of introducing the 2-line hybrid technology, where the heterosis per se also increases. And the key element out here is, can we get low CSP or low critical sterility point temperature point parental lines below 24 degrees centigrade. Now, to give a context to this, what is the current levels of the yield that we saw in our multi-replicated trials, MRYT trials in the HRDC platform? We see that in recent times, we see the increased the heterosis over the best check PSBRC 82. We see about 30%. And this is exactly we saw in our, even in our actual trials on the socioeconomic trials conducted in the Philippines, we see the similar number of 30% advantage of the hybrids over inbreds. And I know that many would appreciate that this is the current level is between 25 to 30% yield advantage of the hybrids over inbreds. Now, looking at the different market segments, and we see the South Asia, Bangladesh, and India, and we see the medium slender grain segment and mid-early segment, and in India, mid-early segment. And you see the potential area that is that you see about 8 million hectares, and the yield advantages that is required in this, if you look at the benchmark, is around 8 to 10% over the existing best hybrid, and over the Czech hybrids is about again 20. But if we are targeting around 25 to 30% in our screening approach, and if you look at the key gaps that are presently in Indian context, where lack of stress-tolerant materials, producibility, the seed reproducibility, lodging, and false smut are some of the key traits. Likewise, in Bangladesh, the cold and disease resistance, including drought and salinity tolerances. So the same market needs that are required in Philippines and Indonesia is also very important. Like in Indonesia, where the BPH with rugged stent virus and BLB and blast and drought are very important to close the gaps. And likewise for Philippines, we have multiple abiotic and biotic stress tolerances is required. And much of this is also on the grain quality, BLB, BPH, and low head rise recovery are some of the key factors. In this context, what climate smart rice hybrids could deliver. So this is a concept again, in order to create this type of hybrids that would have high and stable yields. At the same time, provide the abiotic stress tolerances, multiple abiotic stress tolerances, including drought, salinity, submergence, and the biotic stress tolerances like BPH, BLB, blast, major biotic stresses. And it should match the grain quality features of the different market segments and market checks, and amenable to direct seeded as well as transplanted conditions. Why I refer here on the direct seeded conditions is in the future, we'll see that the direct seeding would become a kind of a trend because of the lack of availability of the irrigation water, especially creating terminal droughts even in irrigated areas. And this type of direct seeded conditions would increase in the coming days. And what are those things will be covered even in this talk. And high resource use efficiency is another important trait. If you look at the phosphorus and these, especially phosphorus is basically from the rock phosphates, these are going to deplete as we see, as we go along, coming towards 2050. Much of these are depleting resources. And many of them are petroleum-based resources where nitrogen, fertilizers, and all these are going to deplete as we are talking. And we need resource use efficiency on the prime topic that has to be in these hybrids as well. And hybridized reproducibility of more than 3 tons per hectare is very, very vital for us. And meeting the market requirements of the target region is the core essence of this strategy. Now, in doing so, we need to understand what is the breeding, how we breed the parental lines for these future climatic conditions. And among the major conditions that I look from a research perspective, the drought and heat tolerance would be very, very vital, and these would directly affect many of these floral traits. Now, if you look at the floral traits that the CMS lines should possess is the long stigmatic surfaces and high seed setting rates, promoting more outcrossing traits. And likewise, the restorer should have heavy pollen load, and dehiscence duration should be able to cover the female parent. And the climate resilient parents with ideal seed production traits, especially higher combining ability, disease resistance, grain quality matching requirement of the market requirements. All these are would lead to eventual adoption or wide adoption of the hybrids. I would like to share one very important slide here. This is which I've shown in many of my presentations in the past. This is a very classic slide where this experiment was conducted in Bohol in the Philippines, where this farmer Apolinar Asa in Kandahar region 7 planted this, we call this line GSRIR 1-8 S6 S3 Y2. It's also called NSIC RC 480 now. And this guy planted this before its release even in this region where the seawater inundates immediately once you, when the nursery is transplanted, and in 4 days after transplanting, he sees the seawater comes in because this is near to the coastline. And after some days, he sees the freshwater inundation of the heavy flooding causes 4 days of complete submergence of 1 meter head over the plant height. And then the plant recovers in the same place, and you'll see the plant recovery in the same place. And in the same place, then drought strikes quickly in this place, and where you'll see the drought cracks in the field. And at flowering, you'll see the crop. It looks very good, and the farmer is able to harvest in these circumstances where 3 major complex traits, salinity followed by flooding and drought. The farmer could harvest 1.2 tons when he never harvested anything. In fact, the farmer was smiling when the seawater came in. He was so sure that nothing would survive. And this is what happened was, generally the farmer would not get any yield. Many of our GSR also were without any harvest in that particular, when we tried 5 of the GSR varieties were planted in that situation. The most interesting thing is what happens in the normal, when the normal things prevailed, the good season came, then the variety shot back to 7.23 tons. And this shift is the very important reason why the Department of Agriculture in the Philippines took this very seriously and increased the adoption area of this particular act. Today, it has been released as NSIC RC 480. It was released in 2 conditions simultaneously, in salinity and rain-fed drought. And therefore, it was named as GSR 8, and it now occupies 0.7 million hectares in the Philippines and becomes the first truly climate-smart rice across the crops. And this particular variety does very well in transplanted condition. It does very well in the direct seeded conditions. It has very good cooking quality, and it looks like this in a normal crop at IRRI. And it has the good cooking quality traits and very good in the saline and rain-fed environments. And it's spreading into the irrigated areas as well. We did a survey based on our socioeconomic scientist from UPLB, Professor Yorobe, who is a lead economist there. And based on his estimations, he found that nearly 1 million hectare has been covered in the Philippines alone. And this particular variety touched about 0.7 million hectares. And it's also very good for including iron toxicity areas. So the reason why I try to show this is basically to give you